Okay, let's now continue our discussion of chemical bonds. Specifically, we're going to refer to bonding with carbon, organic molecules, and polymers. Now, as a kind of a reminder, covalent bonds will form when neither of the two elements has enough strength to completely pull away an electron. Okay, that's when sharing occurs. We said before that this is when you typically have nonmetals and nonmetals. It could happen also with very low electronegativity very high electronegativity atoms that fall into the metalloid category. So our covalent bonds can't pull away an electron. The more unpaired electrons an element has, then the more potential bonding combinations that can exist. So what I'm talking about here is let's say we have fluorine. Fluorine is in the 7th group, so it has 7 valence electrons. As I fill these, I now see we're pretty close to achieving a filled octet. All we need is to share this one lone pair. So this single domain, this single bonding site, has the ability to make a single covalent bond. But that's it. That's all fluorine can do is make a single covalent bond, because the other electrons, no, they're good. Fluorine is so electronegative that there's very little chance that these would be pulled away in a shared bond anyways. If we look at another example, let's say nitrogen. Nitrogen is in group 5, so I have 1, 2, 3, 4, and 5 valence electrons. You see here now I have 3 lone electrons, 3 domains where covalent bonds can form. So nitrogen actually has the ability to make single, double, or triple bonds with other atoms. Now, the most versatile of these would be our carbon atom. A carbon atom has only 4 valence electrons. Now these 4 valence electrons offer 4 bonding domains. So what carbon can do is it can bond, let's say, with another carbon, and it could form a single bond, a double bond, or a triple bond with itself, and still have room to connect to another atom. So carbon has the ability to make these extended covalent bonds with itself and with other nonmetals. Many large molecules that we see are repeated combinations of covalently bound groups of atoms. Okay, so the molecules, you might hear them described as macromolecules. Macro just means large. Okay, they're big molecules. And many of them are combinations of covalently bound groups of atoms. This would be one example of a covalently bound group. Okay, now you'll notice there's room on the left and the right for additional bonds to form. So what we can do is we can take this group and we could join it to another group that's identical to itself. This specific group of atoms is known as a subunit, or this is sometimes referred to as a monomer. Okay, so this subunit, also referred to as a monomer. We also have room there on the right side. We can add on another one of these subunits, and now we have a chain of 3 subunits. If you have more than one of the subunits, it goes from being a monomer to being called a polymer, polymer. So we have this polymer, and the reason that we care so much about this is we see it in a lot of applications. You'll see it in, for example, a lot of plastics. PVC, polyvinyl chloride, is an example of this. Now in the human body, this is something that we actually pay a lot of attention to. In the human body, we have proteins, nucleic acids, as well as starches that come from repeating subunits within the human body. The subunits that derive these come typically from our amino acids. So amino acids we call the building blocks of proteins. Proteins that can be used for all kinds of different things within the human body, from cell reproduction to so many other processes. But our proteins, our nucleic acids, and our starches form the repeating subunits found within the human body. If you recall from biology, these amino acids again are the building blocks. So our adenine, thymine, guanine, and cytosine, you'll see that These are all made from nonmetals, combinations of nitrogen and hydrogen and oxygen. So they come together, they form these long extended chains, extended groups of covalent compounds, and they're used in the human body for a variety of different functions. Now I'll give you a second to pause this, get your practice done, and now I will assume you've done that and continue. Why is carbon found in many organic molecules? Because it has 4 valence electrons. How many types of covalent bonds can carbon form? There are 3 types of covalent bonds. It can form single, double, and triple bonds. A polymer is a large molecule that is made up of many smaller covalent groups known as, we could say, subunits or monomers. Organic polymers include which of the following? Okay, sugars, they tend to be large molecules, but they don't form long extended chains. Starches are included in the list of extended polymers. Lipids are fats and oils that are great at storing energy, however, they don't form the extended chains. Salts are ionic substances, they tend to be small actually. Amino acids, while they're the building blocks, okay, amino acids are subunits. They're subunits, they don't actually, they aren't actually polymers, they're the building blocks of our proteins. So proteins are included, nucleic acids would be included, but amino acids are not. And lastly, carbohydrates. Okay, so carbohydrates, typically in the form of sugars and things like that, are macromolecules, but they are not necessarily going to be organic polymers. Amino acids are the basic pieces or the building blocks of proteins.